thanks everyone for coming today. Really excited to be talking about Git and the rebase workflow. It's something that's very near and dear to my heart. It's something I use quite often. And I want to take you on a path today on how we can teach you basically, so you can walk away today on how to add rebase to your workflow and teach it to your teams and help improve the quality of your code base, your teams, and also your team's efficiency. So we're going to walk through that today. There's a lot to go through here. These slides is kind of power-packed. These will be up online, so if you're a heavy note taker, I do apologize. Try to scramble if you can, but remember, a lot of this is in the slides, so as we go through this, it'll be available later for you to go back and dig deeper into this. So in order to get started, we actually have to talk about kind of key benefits of using rebase versus merge, which is the default behavior when you're using Git. And Git is an obtuse tool. It's not the most easiest to use, and it takes a little while to gain mastery. So again, we'll walk through this together. Some of the key benefits of using Git Rebase is that it creates a linear history. So each of your commits go one after the other really cleanly. In a merge workflow, it kind of branches out and it comes back in. It's kind of a big mess. So keeping it linear makes it also very readable. Because when you're using Git and you're using a rebase workflow, when it's linear, it's also readable because it's easier to go back in time and see what I was doing or what your teammates was doing, or even when you're PRing your code, right? You're having your team look at it. You want to see that the first commit is the beginning of what you were architecting, and then the next commit builds upon that, and so forth. And then the last commit is the keystone, right? That wraps it all together to finish your feature. So keeping it readable like that makes it a lot easier for your team and for you later historically to go back and read why you did what you did. One of the things, all of us as engineers, is that it's not so much the time spent writing the code, it's actually reading the code. And what I mean by that is, if you're spending a lot of time rereading the history, trying to understand who did what and why they did that, and then you're doing the same thing, and then you're doing the same thing, that's costing your team and your company money because everybody's having to reload that into their heads and figure out what was going on at this point in time. So if we can all make it more readable for yourself and the rest of your team, that's money saved for your team and your company. And the last thing is it's debuggable. Because it's linear, because it's readable, it's also easier to debug what went wrong. So if you break out the big tools, and I apologize, we won't get into that today, but if you bring out Git Bisect, and you need to understand when you push something to production, which commit went bad, and you want to bring out Bisect, and if you have a linear history, it's a lot easier to figure out, okay, out of these 10 commits that went into production, which one was the one that went bad and failed the test, or whatever code that went into that. You can identify that commit really quickly, fix it, and get the patch out of production. So in order to really explain this, we need to take a brief historic review here and kind of look at the differences between merge and rebase. And I think it's good to build that foundation so that we're all on the same page and then we can level up from there. So if we look at this, the differences between a merge and rebase, I don't know about you, but the path on the right is a lot easier to read than the one on the left. In this situation here, the master is kind of color-coded in black. And then we've got different colors for different authors making feature branches. And in this case, they're kind of branching off one another and then going back into master at a certain point on the left. That's not as fun to read. But the one argument that some people say when you're using merge is that historically, that's what happened. So that blueprint is there, and you can see that in the graphs when you go through your history. But I would argue that it's okay to lose some of that and actually focus on the right, where each of the color codes, right, is just a different author, a different developer writing code and getting that rebased on the master. And so it sequentially reads very well. It did happen out of order. So on the left with merge, right, you do preserve those timestamps in the history, the actual pure history of how it evolved. But I would argue that rebase on the right, losing that history, or sorry, those timestamps, I should say. You're not losing your history. It's just that it's a little, again, back to sequential, back to linear. It's a lot easier to read. So another way to look at this is merge is really just, it is really merging two histories together and preserving those in time. And like I said, the emphasis on time here, where we have Mariana, who branched off of Ozzy at a certain time, did some work, took her about 22 hours later, and then she finally brought that into master. Again, just kind of emphasizing the branching out and coming back in, right, with the merge workflow. It's preserving that history. So if we look at this, let's kind of like walk through this, looking through a Git log where the commits here in yellow are the SHAs, and the time in which it took place, hours ago, in this case, is done in green. So if we walk through this, you'll see a history here where it's semi-linear. Some of the stuff's been worked on and then it was merged back in, right? And it's not too hard to read, but it's not great. I prefer it to be one after the other, very linear. So let's take another example where this can get out of hand really quickly. So in this case, this is another branch, another team I've worked on, where they just merged everything. And you can kind of see like the last couple commits here 5 hours ago was okay. We kind of got it back in a linear fashion. But as we kind of scroll through this, it starts to get really out of hand because we just merge and merge and merge all the time. So that history is constantly growing. This graph is constantly growing to where you've got basically Guitar Hero. And I don't know about you, but if I have to debug that in production, it's going to take me a while to figure out who of the color codes here, which author did what at what time, when did they merge back in. Like it's kind of madness to debug through that. So another way to look at this is a Git merge. When you're merging, it's really just, you're at war, and you shouldn't be doing that on your team. You're supposed to be working together. So let's not do that. Oh, by the way, it's a little bit of a side tangent. In case you were curious how those logs were generated, I'm using Git graph in this case to make that possible. And then I'm doing some color coding. I'm doing opening up yellow for the SHA here, and then closing the color, starting a green color, printing the committer date, and then closing off that color. So just FYI, in case you're curious how that was done. In Rebase, again, everything's done linear in history, right? The times have changed though. So in that first example, in that first slide that you saw where Mariana was over to the right, and she'd done things like about 22 hours ago, branched off on Ozzy's work. In this case, you don't actually see that connection. But again, I'm arguing or trying to present to you that this is actually okay. In some situations, let me actually caveat that a little bit more. There are some situations like financial institutions, maybe scientific research, where they actually have it as a hardcore requirement where they do have to have merge history because they need it for legal purposes. So there might be a case where you do want to keep a merge history. But in most cases that I've come across in teams I've worked with, it's actually better just to keep it in a Rebase workflow. Again, just readability, linear, easier to read, easier to maintain code. Another way to look at this, in case this helps, is you could have the master branch here in blue, and then you create a feature branch off that master branch, right? You do some work in the red commits, and then eventually when you rebase it, you're replaying those on top of master. So you are now ahead of master, and then you're going to push that up. That's another way to look at it if it helps you visually. Another way to look at this alternatively is that you started off of the master branch, you did some commits, and then when you finally rebase, you just kind of slide it in front of master, so you're ahead of master. So if that helps visually, that's what's happening. That's exactly what rebase is. So let's look at an example of a rebase of a long project that I've been working on for many years, and you can maintain this. This is very possible where I go back 5 months ago, a year, keeps going, but that's a very linear history. It never branches out, never goes crazy. I don't have a whole bunch of merges. It's one after the other. Very linear, very easy to read. So this can be done. So let's look at this a little bit more closely and kind of walk through what like a normal workflow is for every one of us, right? So again, kind of building the foundation so we're all on the same page and then kind of show you what this looks like as we go into our Rebase workflow. So typically, when you start your day, you might pull from master. That, by the way, is actually git fetch and git merge. That's that command. It's actually 2 commands in one. Where we go wrong is because it's got git merge right there. Then we might start some work. So we might check out our branch. To be here is short for branch, and then we'll track it. This is a power tip, by the way. This isn't quite necessarily part of the Rebase workflow, but I want to present it to you as another power trick added to your toolkit. The tracking, what this is doing when you set up the branch, is it's going to track with remote. So any changes that happen on remote, every time you pull or sync, those changes are going to come down to your local branch. So turn this on. You're going to thank me. It's just a wonderful way to keep your local branch and your remote branch in sync. So just do that or alias it if that's easier for you. You do some code. You'll add some. You do a git add some changes. Maybe fix up some things. You keep committing, and you kind of repeat that pattern, right? Now you're ready to push this up, maybe PR. So you'll check out master because you want to get the latest stuff that's happening for master. Your team might have been ahead of you. They might have got their work done before you did. You pull that down. You check out your example branch. And then you'll basically get pull origin master. You're going to merge the changes from master because they're ahead of you into your master branch. Now you're smashing all this stuff in there, but that's how we all kind of start as early developers figuring out Git for the first time. And then the last thing we do is we finally push that up, right? We've basically merged that stuff into our example branch, and now we're ready to push it up. And at this point, maybe we PR it, right, so that our team can review it. So that's the merge workflow. So let's actually not do that, and let's look at this another way and see how this contrasts when we actually switch to a rebase workflow. So to do that, we'll start with synchronization as we did before. Same commands, but I'm going to argue that don't do git pull. Just don't do that. Switch to git fetch. You'll fetch the changes upstream, pull them down. They're not applied to head yet. You're just fetching the changes. And then I would argue, as another power tip, turn on pruning. And the reason this is a nice power tip is that when you fetch and prune, if any of your teammates have deleted branches on the remote repository, prune will automatically delete those locally for you. So now you don't have this, you don't have a whole bunch of branches that you have to maintain and just keep growing and growing and growing because the team deleted them remotely, but you didn't manage to update it locally. So this is how you sync that locally. I would recommend turning this on. It's a really nice feature. But it is destructive. It does delete those branches locally. But again, your team deleted them on the remote branch, so there shouldn't be any problem for you to delete them locally. The next step, though, is to rebase. So instead of git pull, we'll say git dash dash rebase, and that changes it from the default behavior merge to finally rebase. So now we are rebasing. We'll start work, and this is actually the same as merge. There's no real change here. We check out our example branch, do some commits, repeat, rinse, and repeat. Keep on going until we're ready to push. So when we push, again, we're going to pull, also going to force rebase. It's very important so that we don't accidentally merge again. When we do the pull, when we check out to our example branch, right, we want to update it as well. We want to rebase it on top of master. So we've rebased master now. It's ahead. Our branch is behind, so we're going to rebase it on top of master so that we're ahead. We're the first commits again. And the way to do that is just insert rebase into there. And the last thing we're going to do is we're going to push, but we're going to push with force with release. Now, some of you probably know to just git push force. That's pretty brutal, and that's really unkind to your fellow engineers, because in the case where you might be sharing a branch together, I don't recommend this, but let's say that you are working on a feature branch together, and I happen to hand it off to you perhaps, and you're making some changes and you push those up. If I come along and I do a git force push, I'm going to override his changes. That is not very nice. So with force with least, if I turn that on, if somebody's beat me to the punch and we didn't communicate very well, again, I don't recommend this as a procedure to do. I think we should be pairing at that point and on the same branch together. But let's say that I'm busy in a day and somebody else, still had energy to go on. They might push, you want to do a push force with least. And what Git's doing in that case is saying, hey, hold on a second. There's changes up here. You're trying to force on this. I don't think you really want to do that because it's changed on the remote branch. So I'm going to actually not let you do that. This, by the way, is a really powerful feature and something you should just add into your normal workflow. There's talk that in future versions of Git that this will actually be the default, and you'll have to actually optionally say dash dash force with, they might call it something different, but actually physically just blowing it away. So turn that on. So some quick tips. Now that we've kind of gone through that workflow, let's actually level up a little bit better. First off, in your Git configuration, you can just say for pull rebase, set it to true. So like we were typing before, git pull dash dash rebase, I don't want to type that all the time. I just want it to happen. So by turning this on, we can always have automatic rebase, and we can just say git pull, and it's doing rebase for us. So turn that on. And then, by the way, if you want to run this from the command line, here's the command line to do the same thing. It'll just update your git config so it has that setting. The other thing to do is fetch. So when I was telling you to fetch and prune, you can also turn this on so that it just automatically does that every time. So we don't have to type git -- prune all the time. We just say git fetch and it's pruning for us. So turn that on as well. Add that to your git configuration. And again, from the command line, you can set it that way too. So this brings us to interactive rebase, where we kind of pull up big guns here and actually start to see what this looks like when we're rebasing locally. The way to do that is just a simple command, git rebase, and then -- interactive. I'm spelling this out for you because it's easier to read and easier to talk about, but most likely in practice you're just going to use -I. That's the shorthand for it. What's going to happen when you do that is, actually, sorry, I should go back really quick. I'm rebasing off a master there. That's important because I'm going to be most likely in my example feature branch, so I want to rebase on master, right? Because that's the branch that I branched off of. So that's why master is there. We'll get into this more here in a little bit. So then you're going to be in the editor. So in your editor, Sublime Text, Visual Studio Code, whatever it might be, you're going to see this. And at first it's kind of daunting because there's a bunch of commits that you just done on your feature branch. And it's like, hey, I'm going to pick these for you. And then it's saying some diagnostic information. It's saying, hey, for this SHA, we're going to rebase onto this other SHA, right? In this case, which would be the master SHA. And then I'm giving you some commands here, and by the way, thanks Git. You've given me a little cheat sheet here, so I know what I can do. So this is really nice. So we'll get into this, but I just want to show that, present that, and then we'll dig into this in a little bit. There's a few more things I want to talk about interactive rebase before we get into the editor. So one of the things you can do is you can interactive rebase, and you can go back a number of commits. So let's say that you have 5 commits on your branch. You want to go back to the 3rd commit and rebase from there. So instead of rebasing all 5 commits, you're just going to rebase the last 3. So you'd say @ symbol tilde and then the number 3. By the way, the @ symbol in this case is just short for head. So if you want to type out head, you can do the same thing. That's exactly what it's doing. It's just saying from the head commit, right, go back. That's another way to do that. You can also rebranch from interactive rebase from a branch. Now, why is this useful? Well, in many cases, this kind of gets into more really advanced techniques. But let's say that you've PR'd your work. You've got those 10 commits up there. You've got it PR'd, and for some reason your team's really slow. It takes them like a day or 2 to turn around. You're like, oh my gosh, I got to take what I did there, and then I need to build off of what I had. So you'll branch off your branch. This is kind of called like branch chaining. It's a little bit more advanced, but I sometimes have to do this because I've got that code up for review, and I still need to continue down whatever feature branch work that I'm doing. So I'll branch off the branch. So in that case, I want to do an interactive rebase off of not master, but example in this case, and then my new branch might be example 2. I know these are terrible names, but that's what you would do. Is on my example 2 branch, I would interactive rebase off of example because that's the code that I'm working off of. And that's where this comes into play. So it's a really nice technique. The other thing you can do is tags. So I've actually never used this myself, but you can do it. Where I'd see this coming into play is like maybe you've released version 1.0. You tag that. And for some reason you want to create a new branch off that tag. And so you can rebase from that tag because you're starting to release 1.001. Because that's your fixed release that you're going to put out. So you might want to rebase off that tag. Again, I don't use this too much, but I'm just presenting it. It's there for you as a tool to use. Another common way to do this is not the numbers, like we were going back when we were saying three commits back. You can also say just the SHA. So if you have 10 commits there, and maybe the 5th one, you're like, I don't want to count. I just know it's that SHA. I'll just say, hey, start there and rebase from that point. And interactive rebase will start from there and say, hey, what do you want me to do? You can also upstream. So if changes have happened upstream on your feature branch, you can say, hey, just rebase from there. Not anything here off my branches or tags or versions or whatever. You can go upstream. I don't use it very often. again, just to present that that is a tool in your toolbox. And the last one is root. I love this one, but a big warning, if you rebase from root, that's from the very first commit in the repository ever. And you're thinking, hey, why are you telling me that you can do this? Well, there's a really good use for this, and I use it often, especially when I'm open sourcing new work, or I'm working on a team where maybe I'm doing some of the initial plumbing, and I'm building out this new project, and I'm just constantly rebasing. So I want to rebase off of root, the very first commit, because I haven't pushed any of this stuff up yet. So I'm just constantly refining my code, keep working on my feature, getting that initial implementation out. Maybe there's a bunch of documentation that needs to go into it. Who knows, right? But I'm kind of off on my island a little bit there, and I'm just getting this really cleaned up so that when I finally PR this, those commits are really clean for the rest of the team to actually start looking at this for the first time. And so this is a nice gesture of kindness to the rest of my teammates, that they haven't seen how the sausage was made. I just got everything perfect so that they can review it and we can actually have a good architectural discussion. So that's where root comes into play. Yeah.
So you're saying in that scenario, like 5 commits will be turned into 1 commit for the actual rebase, so then you'll only have a commit for each rebase?
No, what's happening here when I'm rebasing, so, sorry, let me repeat the question. He was saying, like, if I had 5 commits, would that squash them all down into 1 commit when I'm rebasing root in this case? No. What I'm doing is, I'm 5 commits, I've just made 5 commits on my feature branch, and root just goes back to the very first commit and just shows you all 5. It's like, hey, what do you want to do? Do you want to reword this one? Do you want to pick this one? Do you want to drop this one? They don't go away, unless you say specifically drop them. But yes. Does that answer your question?
Yep, thanks.
So in the last one, this is a really advanced technique, but I want to present it to you because I actually use this quite a bit. I call this, this is my alias for it, but GRA for Git Rebase Advanced. But you can do interactive rebase like I've been showing you all along. But you can do this little trick where you say editor true in front of it, and what that'll do is it won't pop up the editor. So if you've done a lot of fix-ups, and we'll get into this, I'll show you what these look like. But let's say I did a lot of fix-ups, and again, we're sausage. But I don't want to show that to anybody. I also don't want the editor to come up because they're just fix-ups to previous commits. So it'll just rebase it, and if there's no conflicts, it'll just all do it in the command line without popping up the editor. So this is a really advanced technique. It's super awesome. I use it a lot because it speeds me up considerably. Just presenting it there as a nice trick. But again, you need to feel comfortable doing rebase. And again, we're going to go in this together, all of us, to how to get those techniques so that you feel more comfortable doing this. But I do want to present it to you as a nice speed up trick. So let's get back to the editor here. So we're in this editor and we're interactive rebasing, right? We've got our 3 commits, not so much 5, but 3 in this case. And I want to focus on these commands down here. And I want to walk through them all together with you so that we can kind of talk through and actually expose some things that you probably already know, but also talk about some advanced techniques there as well. So one of the first things is that you can actually do shorthand for this. So instead of typing out pick, or you can say P, you can not type out reword, you can say R, and so forth, right? You can type those out if you want to, but I prefer to actually just use the one character and be done with it and move as fast as I can. So highly recommend getting used to using that. And again, just you can type those out if you want to. So let's focus on pick. We'll start there and kind of work our way. When you're picking, that's just the default behavior when you get interactive rebase. It's just going to present you and say, hey, you've got these commits. And again, this is kind of, abstract a little bit, but just pretend this popped up in your editor, and it's got all the commits there that you want to pick. So in this case, it presents us with that ability to do that. Now, one of the things I want to point out is another advanced technique that you don't really learn until you actually really get into the in-depth of doing really advanced Git Rebase workflow, is that you can reorder these. So one of the nice things is let's say that the fixed JSON schema, my last commit there, I really realized that I actually really want that to be the first thing that I did. So, and the reason I bring that up is because, again, when I PR this, I want this to read like a book, right? So when I'm in GitHub and I have this PR up, I want you to be able to start on the first commit and then use the keyboard shortcuts of N for next commit, or P for previous commit, and just hit next as you read through this. And you're just like, yeah, okay, looks good, as I build up the story of how I built this feature branch out or fix this problem. So again, emphasis on not a lot of churn, just being able to read this really nicely as you kind of go through and understand how I built up what I did. So you can reorder those. And what's nice about that is if we want to take the fix commit here and actually make it our first one, we can move that up. And if we change that, we just change it like that in our editor. We just move those up. We save it and then exit the editor. And then what Git will do during the rebase is it'll just rewrite history. So now our fixed JSON schema is our very first commit, and then the others followed after that. Again, a little bit of a contrived example, but this really pays off dividends when it's trying to communicate to your team and as they're reviewing your code on why you did what you did and how everything built up. So the next one is reword. This is something I use often as well. Again, you'll be presented with the commits that you want to change. Let's say this middle one, for example, we're just not very happy with that subject. Added documentation is just not verbose enough for us, and we want to actually reword that a little bit so it's a little kinder. So what we can do is we can type reword here, and then save that. And then what Git's going to do is it's going to say, oh, you want me to reword this? Great. Now it'll pop up that commit into your editor and say, okay, well, what do you want me to do? And in this case, we want to change the subject, not so much the body, but the subject. So we can rewrite this so that it's added contents, documentation to the README. So now it's more specific. Again, I know this is a little contrived, but it's more specific. It's a better commit. I know why or what it is that you're doing. And in the case of the body, I'm actually pretty happy with this. We could change this if we wanted to. We could reword this as well. But in this case, I'll leave it. We'll just change the subject. And this is important because when you look at the anatomy of a commit, your what is always your subject, like in an email, right? Your subject. That needs to be succinct, and it needs to be what it is that you're doing. In the body, it's always the why. It's to support the subject. Why did you make this commit? And the reason that's so important, again, for your help, for yourself, historically, if you forget and get vague on things like, why did I do what I was doing back then? Oh, I explained it right here. And it's also kindness to your fellow team members. So if we go ahead and do a git log on this, and we print out those commits, you'll see now that the second commit there is nicely reworded. When we saved that file, Git did the interactive rebase, it changed the wording of the way that we wanted to, we're good to go. So, edit. Edit is a lot like reword, a lot like reword. And you might just pick one of these, like this first one, you change it to edit, or E for short. I'm not going to go into that in this case right now. It's a little bit more advanced and a little bit more to set up to give a good example. But I will say that it's a lot like reword, but the other thing it lets you do is it actually allows you to change the commit itself. So the code that you were, the code in that particular commit, you can go ahead and amend that, add additional files, do other things, right? And then finally continue with Git Rebase and continue from that point. So that's a nice thing. And the reason I point that out is because I'm picking the first commit here again. That's several commits back, so if I want to edit that and fix that, this is the way they give me. This allows me to go back in time with interactive rebase, fix that commit, editing it in this case, do my work, continue on, and then Git automatically rebases, and it's good. It's like I patched that on my head to begin with. That's not true, but it sure looks good in the end. So Squash, Squash is another powerful tool. The way this works is, we'll pick a couple of these. Like let's say we pick these two commits right here. We'll change those to Squash. And then what that does is that's going to bring up the Git editor. And actually I jumped ahead a little quick. Those two squashes, what that's saying is these two commits, those last two, are going to be squashed into that first commit, the one that still has the pick. So we're going to squash that down. What that looks like in your editor then is a whole lot of text, right? But it's going to say, hey, look, here's your 3 subjects from those commits, and here's the associated lines for those. What do you want me to do? Well, at this point, when squashing, we can be like, well, look, this last commit was affixed to the JSON. Well, since we're still working on the initial implementation, let's just take that away because I'm just going to magically fix it now. And it looked like I did it correct the first time. So we'll take that out. We don't need that text. Nobody needs to know that. In this case, this subject here for adding the README, well, again, we're squashing this back into the initial implementation. So why do I need to tell you that? Let's just take that out too. So we'll get rid of that. And then the last thing is now we've got our subject, but these 2 paragraphs don't really make a lot of sense. So why don't we just combine those together? So let's go ahead and fix that up too. So I'm happy with the subject. I'm not so happy with these two paragraphs. So let's just reword that so that we take out this sentence and then combine it. So adding the initial implementation with README. And by the way, with the table of contents, sorry, this is a general line, but it builds a table of contents in Markdown. It was generated with this particular tool. So now we've set it very succinctly. We squashed that down. It's into one commit now. And it's all nice and tidy. And then this is my favorite one, fix up, which is a lot like squash, except it doesn't give you the ability to edit your commits, messages. So in this case, we've got our commits again. We want to fix one of these, or fix up a couple of these. We'll change this one to fix up. And then the other key thing here is notice how I moved it up. Because I'm saying fix up, when I save this, it's not going to prompt us anymore like we did with squash, because it's like, hey, I know you want to fix this, but you didn't tell me you actually want to squash or change anything to the commit subject or the body. So it's going to immediately fix it into the commit ahead of it. So in this case where I fix the JSON schema, it doesn't make sense for that to be fixed into the README because the JSON schema fix has nothing to do with the README, but it does have everything to do with the initial implementation. So let's fix it there. So we move it up so that when we save this file, it'll fix it up into that previous commit. So if we do a log on that, we'll see that those 3 commits went away. We just have the 2 commits now, and the fix is actually in the first commit, the initial implementation. Exec is another powerful tool. Again, you'll type this out, and you'll just say exec in this case to execute basically on a particular commit. Again, I'm going to leave this kind of up to you as a journey to go down. This one's a little tricky to describe, but basically what it's doing is it allows you to do execution. So where I've seen this used more typically is trying to run a script with the commits that you're trying to define as executable here, because you might want to run tests on those, right? Like maybe you've changed some things, you want some things to run at the same time when it's rebasing. So if any of those scripts fail, it'll halt right there and then allow you to fix it or continue on. So I kind of leave that up as a journey for you to go down, but just know that that is a powerful tool if you need it. And then drop. Drop's pretty straightforward. Again, looking at your commits, you might pick one of these and you say, look, you know, I added the table of contents, but then I realized nobody on my team seems to care about table of contents for some strange reason, so I'm just going to drop that. And when I say drop, and we save that file, and we do a git log, and we look at the changes, we'll just see that, hey, that commit magically went away. That's really handy too, because a lot of times I might be working on something, I've got 5-10 commits down into my feature branch, and I realize, that second commit that I did doesn't really make sense anymore. I don't want to have to rearrange these commits to get rid of that code. I can just open up the interactive rebase editor, say drop, and it'll just take it away from me. I'm good. So there's some things that we need to talk about that we haven't, now that we've gone through all the commands in interactive rebase, is the conflict resolution. And this does hit, and it is kind of scary at first when you've never done this before. So we need to talk about that. The thing there is, when you're in the interactive rebase and it stops, and it's like, uh-oh, I have a merge conflict here. I don't know what to do. Help me out. That's where you go in and you amend your commit or fix it or deal with the merge conflict, right? You amend the commit and then you can rebase continue to go on. But let's say you screw that up horribly. And you're just like, oh, I don't know what I'm doing anymore. I just want to get back to where I started. Well, this is your escape hatch. You can take Git Rebase -- abort, and it'll just bail and send you back to where you first started interactive rebase to begin with. So that was something that was kind of an eye-opener back when I was much younger, didn't understand how this worked. And this is your escape hatch. So if you're feeling nervous and going down this path for the first time, you've never done this before, you're like, what is this craziness? This is your escape hatch to get you back to where you started. The other thing you do is, like I was saying, when you amend a commit and it's hit a merge conflict, you got to make the changes, you need to amend it back. You do all the amending, fixing, whatever you need to do. Then you can say, hey Git, I'm done, because it's just sitting there waiting for you to resolve the conflict. You can say Git Rebase continue, and it'll continue on. The other thing you can do is skip. So in some cases where you're fixing the conflict, it might turn out that actually after you resolve that, Git realizes, I got nothing to do here. But it still wants to prompt you. It'll say something like, no head, or I forget what the actual message is. But there just won't be any changes when you do a Git status in the middle of the interactive rebase. So you can just say skip, and Git will just go on moving to the next command's rebase. And the last thing, this is actually new. I forget what version of Git this is in, but it's in the most recent one, so make sure you have the latest version of Git. But you can also do a show patch. This is really handy because when you're stuck in the middle of that interactive rebase, and you want to see what it is that you're actually rebasing, what commit you're at, and you want to see the diff, this will actually print that out for you. So that's really handy. It's a nice tool to give you context of where you are. So remember that. And also, that's a lot of types, maybe alias that to whatever feels most comfortable. So back to fixup again. The thing I love a lot, there's a faster way to do this. So when we were in the editor, bringing up the editor and telling Git, hey, fix up these commits, well, actually, you can do this from the command line too. So this is a super powerful tool because you might be 5 commits in. And actually, let me walk through this a little bit because I do have this visually for you. So if we do a git log, we look at our commits here, and we're saying, hey, I want to fix up this commit, and I'll give it the SHA. So in this case, they have to match, right? These 2 commits have to match because I'm going to fix up that commit. And then let's say I fix up this other commit too, the second commit. So I'll say, hey, Git, just fix that one up too. Again, I've amended some changes. I've changed some files, added some files at this point. Now I'm going to say fix up to that commit. What that's going to look like is when I do an interactive rebase, is it's going to put those fix-ups right there next to each commit. Now, for some of the people in the audience, you might be, hey, that doesn't naturally happen by default. I'll explain why these commits automatically got put in the right position. I'll explain why that is. But, because it's a config feature that I have turned on, but I'll show you that in a bit. But what's nice about this is Git's saying, hey, are you cool with this? Because you told me to fix those up. It's going to use fix up bang as the syntax and put them right there where they need to be. The other thing to point out with these fix up commits is that Git's not terribly intelligent about this. The way that it does the matching is by the subject titles. So it matches, it figures out where to put the fix up bang commits, messages basically, based on the subjects. They have to be the same. So if you decide to get fancy and you reword that first commit to something else, and then you still have that fix-up in there, it's not going to know where to put that. So just FYI, if you decide to get a little too fancy in your rebasing, rewording, and so forth. Same thing for this fix-up, right? Subject managers have to match. So now, if we go ahead and do a git log after we've saved that, we let the interactive rebase kick off. Now we've got our 3 commits again. They were fixed, but they're not there anymore because Git magically fixed those up for us. Same thing with Squash. So Squash works the same way. I'm just going to walk you through this really quick. If we, again, we pick a couple of these, we say we're going to squash this one. It'll prompt and it'll have a squash bang there. So instead of fix up bang, it has squash bang. And then what's going to happen there is when we save this, it'll actually halt at that point, and we're back into the editor saying, hey, you've got these 2 commits. What do you want me to do with this? And then you need to reword it, make it really nice so that it has a good subject and a good body for fellow developers to read. And again, it matches on those subjects, so don't change those. Another useful tool to have in your toolbox is Git amend. So again, from the command line, just like fix up and squash, you want amend. The way amend works is it amends the very last commit. So the current commit that you're on, any changes that you make, you're going to amend to that commit. So it only goes 1 back. This is really handy when you've committed something, you're like, oops, I have a typo or some silly mistake. You can just amend them really quick. Another powerful feature, though, is you can say no edit. So let's say that you make some changes to that commit. You add some additional files. Maybe you delete some stuff, and you've amended that all up. Or Git stashed it, basically, Git add, right? So it's in your stash. And then you want to amend that, but you really don't want the editor to pop up, because if you say no edit, then the editor won't pop up, because maybe you don't care to change the subject or the body of that first commit. You just don't care, you're just fixing it. So you can say no edit. That saves you a step. So it's not in your editor, you can just move along really quickly. And if you want to get even fancier, oh, by the way, I actually use aliases for this, so this is just me and my mnemonics, but G amend H, so Git amend H, or head in this case, is my fancy way of keeping this so I have a short tool on my bash. Again, I leave it up to you to whatever makes sense for you, but this is how I use it. The other powerful technique is to also not edit and also add all. Now, you need to know what you're doing, but let's say that you committed, you made some changes, and you're like, I just want everything in there. So it doesn't matter that you've stashed things. Maybe you added a new file, and you haven't done a git add on it. Well, this is going to do that. It's going to add everything and shove it into that last commit. This is super handy because sometimes I'm fixing not only the previous commit, but I also realize I have additional code I need to add in. I don't want to do a git add and then all that extra step. I just want to do it all in one command. So you can do that with all in that case. And in this case, this is my shorthand, command A or git amend all. So let's talk about some tips here that I kind of hinted at. In your configuration, and I highly recommend you turn this on, is you can set up rebase to auto squash and auto stash. So let's, and also those are the commands form as well. With auto squash, we haven't talked about this yet, but it has to deal with, or actually we kind of have. When I brought up the editor, and you saw that we had those fix up bang commits, and they were nicely placed after the commit that they were supposed to be fixing up. Git knew to automatically move them there because the subject titles are the same, right? The way Git knew to do that is because I had auto squash true turned on. So there's no reason not to have this off. So please turn this on so that you have less to do when you open up the editor. The other thing that we haven't talked about is stashing. So auto stash, what's really nice about that is you might want to rebase your commits, but your current working directory is dirty. You've got maybe a file you've added that you haven't added yet. You maybe changed a file or stashed a file, amended a file so it's in your staging area. And you don't really want to do anything with that. So your workspace is kind of dirty. Now, if that's set to false, Git's going to like say, hey, I can't interact with your base because I don't really, you've got some changes here, but I don't really know what you want to do with them. So what Git will do is it'll automatically move that into the stash for you, kick into the rebase, you'll do all your rebasing, and then you save, and then it rebases, and then when it's done and everything's clean, Git will just automatically pop that back out so that you're ready to work. So please turn this on. I do a lot of that. I always have like a dirty workspace, and I just don't want to have to stash it myself, so Git will just nicely tuck that away, pop it back out when I'm done. So turn that on. There's no harm in doing this. The other thing too, and I wish we had time for this because this is actually really cool, but this is Git Reverie or re or however you want to pronounce it. But you can also configure this too. This is really advanced, and it's really a good thing to add into your toolkit, and I can't really give you any reason why you would not want to have this on it. So you want to enable it by default. It's turned off by default. And then you want auto update on. And the reason you need to also enable it and then also turn on auto update is because when you're doing a conflict resolution with your interactive rebase and you've resolved the conflict for Git, Git's going to record that using re. So it's going to put that conflict resolution into, it's basically in your Git folder. So to get technical a little bit, it's in the .git folder, and then there's a .rr-cache folder, and it keeps those conflict resolution patches in there. And so what happens is that if you're rebasing constantly, you've got a long-running feature branch for some reason, and you're rebasing constantly, and you're constantly fixing that stupid commit where somebody changed the indentation or something, right? And you're constantly fixing that, and you're like, I don't want to do this anymore. When you turn on it'll automatically record that conflict resolution, and it'll be like, hey, you know what? I've seen this before. I'm just going to auto-replay that and fix it for you, and it won't ever prompt you again. It's a super awesome power tool. It is so awesome to see. When it comes out in the command line, in the print, you'll see something along the lines of like three-way merge conflict resolution resolve or something of that nature. Sorry, I should have had more examples so you can kind of see that. But that's what will be in the output when you do the rebase. You can just sit back and go, yeah, it's pretty awesome. I resolved that, and now I don't have to do it again. So please turn that on. And again, from the command line, in case you need those, that's the other way to turn it on. So you might be thinking, and I know when we're all thinking, we put a monocle on. It would be kind of nice if you had like a little buddy or a little bot to kind of help you along. So that would be a nice place to be. So there's a tool that I built. It's called Git Cop. It's basically like a linter. So think of it like if you're a Ruby developer like me, you might have Rubicop to like style guide and make sure that your code's good, it's consistent and it's clean.
I built GitCop, and I'm just going to talk about this just briefly. Is that it's there to kind of help knit and check that you're actually staying consistent across the team. So it'll make sure that if you prefix your commits, that they always start with the right kind of prefix. So what's really nice about this is if you accidentally PR something, you have to fix a bang and the squash in there, and your team's kind of like, hey buddy, why didn't you fix this before you PR this? Well, GitCop has you covered. It'll be like, hey, you can hook this in locally into your Git hooks, or you can put it on CI and it'll fail the build. So it just fails and says, hey, you can't do that. You can't have a fix a bang or a squash in there. Don't do that. So that'll help you. The other thing too is to make sure that it's got nice punctuation. So if you're building a change log, your commits can actually work for you in that regard. It'll make sure that you have a space between your subject and your body. Make sure that you have 72-line characters, so it's nicely word wrapped, and you don't have somebody just have long sentences that go on and on. You have to scroll horizontally. GitHop's there to help you. Anyway, FYI, in case you want a little coding buddy to help you along, you can install it. It's a root gem, so you can install it, and then you just change it into your project. If you want GitHop and police it, and it'll start giving you the output right away. It'll tell you exactly which commit failed, what the reasons are, why it's mad at you, and it'll give you the conflict resolution you need to do, which then you can then jump into Git Rebase and fix it. So next steps. Next steps for this. Now that we've kind of walked through this, and I've kind of taught you, kind of shown you between merge and rebase and how to get into the rebase mind flow. The next step is to basically, hopefully, walk away today with this workflow. You can, again, these slides will be up so you can use them and go through them yourself. But just practice this every day. It takes time. There's no silver bullet for this, but hopefully I've kind of encouraged you to start to go down this path so that you can keep clean history. The next thing is update your dot files. Add those aliases in. Make functions out of them. Whatever it is that'll make your workflow faster. Just make it as succinct as possible so you can just be as fast as at your job as you possibly can. And then the last thing, of course, bring in GitHub and add it to your project. It's a nice way to keep consistency across your team. And even if your team doesn't buy into it and you just run it yourself, again, you can wire it in globally as a Git hook, and it'll just help you. I know that was a lot. I just want to thank you all for going through a really dry subject, a tool that's very obtuse, and I hope you learned a lot today, so thank you. Is there any questions? I know that was a lot. I went kind of fast. Yeah.
Is there a way to undo drops similar to copying stash, or do you have to go back to reset?
So the question is you want to know if you can undo a drop. So that's a good question. So if you tell Git during interactive rebase to do a drop, and that's actually not what you wanted, if there's no conflict resolution, there's no way for you to do a Git rebase abort and get out of it. So in that case, this is a bit more advanced, and we can talk about it a little bit more offline if you want, but you have to bring out another tool, which is Git reflog. And what reflog is it's basically a log that's kept in your Git folder, and it actually has the SHAs of all the changes that you've made, and you would have to figure out where the SHA was before you did the drop in the rebase. And then basically, you do have to do a reset hard to that SHA, and that'll bring you back to the place before you started doing the rebase and you did the drop. I know that's not the best way to explain that to you, but that is actually the answer. But I would have to probably walk you through how to do the reflog if you've never gone in there before. But that is your power tool to get you out of a situation like that. But that is a very good question. Any others? Yeah.
So is a rebase workflow, or can you transfer a project into it?
Yeah, so excellent question, thank you. So the question was, is a rebase workflow compatible with a merge workflow? Not necessarily, but you can pull it off. So if you can't convince your team to do a rebase workflow, you can't get everybody on board to be like, yeah, we're going to rebase all the time. You then can say, okay, all right, fine. I'll do it on my feature branches. So you can live as a rebaser within a merge team, by always rebasing on your feature branch. So I would encourage you that if your team for whatever reason can't change and they need to stick with a merge workflow, just rebase on your feature branch. Keep rebasing, and then when you finally PR it, you'll have a very concise, short history that's very linear. Yes, eventually they'll merge it in, and yeah, you lose that linearity, but at least you did your part. So kudos to you if you go down that path. Okay, just one more question, and I guess we got to wrap it up. So, oh yeah.
What's the advantage of this over having the PR automatically squash commits?
Yes, good question, yes. I've seen that a lot in teams. So what they do is they keep a merge work. So sorry, let me repeat the question. The advantage is what is the advantage over rebase versus a team that basically just does an auto squash on everything, auto squash merge basically. I would argue that try to get away from squashing if you can, because as you saw in the example where I showed you the squash editor, right, and it had all that, when that auto squashes, it's just going to leave it like that, and that becomes your commit, which is really hard to read because you have a subject, but then you have subjects and bodies within that commit message, right, that's been all squashed into one squash message, and that's not fun to read because I have to spend time reading, understanding why we squashed it that way, and trying to figure out what all went into that. And the worst thing about that, auto squashing, is all those commits that went into that are all now in one commit. So the implementation, the tests, and everything associated with it is all one master blob, right? And so I gotta tear through that and figure out why did we do what we do, and it's really hard to debug that. So if you can, please avoid that. But yeah, thank you. That's a really good question, and I would say try to avoid that if you can. So he's telling me I'm out of time. So thanks everyone. If you want to catch me later, please seek me out. I'm happy to talk about it.